Okay. So, hello, hello. Hello, hello. There's this song. You know what? It doesn't even matter. My daughter likes this song and I forget his name, but it's like, hello, hello, can you hear me? Da-na-na-na-na. Deep in the dark, I can see the light. And it's this guy. It's really catchy. It's like a club song. You go to the club, right? Dance like that. Okay. Such a nerd. Okay, let's go. Let's go. So first of all, Leah, let's understand what the question's asking. Let's underline anything that's important. Leah drives her car to the mechanic. Then she takes the commuter rail train back to her neighborhood. So she takes her car to the mechanic. This is there. She goes there. And then she goes back. Okay, there and back. Okay, the average speed for her 10-mile trip. Okay, total distance, 10 miles. That's important. Let's underline it. Is 15 miles an hour faster on the train? Look at plus 15 because the train goes faster, obviously. And then look at her little, looks like a yellow Mercedes, like two-door thing. So her speed going there is just like whatever, R. But the train goes faster, so I R plus 15. So now it's 15 miles or faster. So this is important and this is important because that's my rate, my speed, my rate. Find an expression. First thing I need to do, find an expression for Leah's travel. Second thing I need to do, if she drove 30 miles, find out, the expression and then find out, oh, well, if she's going 30 miles an hour, how long did it take? So how long is really what I'm asking. I don't know the time. I know how far she went, the distance. So we know distance equals rate times time. We've learned that for many years now. But I want to know the time, which means that I need to solve for t. I need to get t alone. And t equals, when you solve for t, distance over rate. Okay? So that means that on the time part, I need to put whatever distance is over the rate. So let's actually try and fill in this box. The distance, how far did I go? Well, they both went the same, okay? They both went 10. So now, the rate, how fast did they go? Well, the speed of the car is this variable here, it's an R. The speed of my commuter rail train, it's like an above ground subway, R plus 15. Which means that I need to put my D over my R, my D over my R. So it's basically the time is distance divided by rate. I'm not going to put in a whole nother number for time because I don't know how long. So distance divided by rate, car, 10 divided by R, distance over rate. Commuter rail, distance over rate, 10 over R plus 15. Does that seem okay? I need to know the time. And remember, she goes there and she comes back. There plus back. This is an addition problem. There plus back. So there plus back is going to look like 10 over R plus 10 over R plus 15. So what I want to do is I want to make a whole new, like, what's the common denominator? How do I add these two fractions? Well, the denominator, what's my LCM going to be for an R and then an R plus 15? What would LCM be?
R plus 15.
Just r plus 15? Because what happened to that?
R squared.
Well, I will not distribute it, but I'm going to put both r's. So it's going to be this. R plus 15. Remember, I want you to leave them in parentheses. Plus r plus 15. Okay. Now let's do the math. Let's find the common denominator. Let's find our new numerators. So it was r. Now, oh wait, I better put the tens on top, hadn't I? Yes. It was an r. Now it's r times the quantity r plus 15. So now it's both. So what am I missing from r to get r plus 15? What's missing? Someone new.
R plus 15.
Yes. So this is r plus 15 multiplied on the top. So you're basically multiplying whatever's not on the other side. You're multiplying what's on the other side. So this 10 had an r, but there was no r plus 15. So I multiply r plus 15 on the bottom, r plus 15 on top. This fraction has r plus 15. What does it not have? Doesn't have an r. So I multiply r on bottom. There it is, r on top. And distribute 10r plus 150 over, plus another 10r. Might as well just put them all together. And r plus 15. So 20r, combine like terms, 10r plus 10r, 20r plus 150 over r plus 15. There's my expression. That's part one. Done. I found my expression. I added the fractions. Next thing I'm going to do is I'm going to do step 2, which was if she drove 30 miles an hour, if r equals 30. So here we go. 20 times 30 plus 150 over 30 times 30 plus 15. Do the math, I'll just help you out. It's 750 over 1,350. Reducing is 5/9. 5/9. Okay, so check this out. I need to know how long it took her. That's minutes or hours or something. 60 minutes divided by, cut up into 9 equal parts, 5/9 of an hour. So what's 9 parts of 60 minutes? 60 divided by 9. Each part is 6.6 minutes. And if I want 5/9, then I'm going to do times 5 and get 33 minutes, approximately. 33 minutes and 20 seconds. But seriously, like 33 minutes.
So like the 5/9. So how did it turn into the minutes again?
5/9 of an hour. So that's just you figuring out. A clock has 60, an hour has 60 minutes. So what's 5/9 of an hour? So I did this math. You can do 60 times 5/9, but I did 60 divided by 9 times 5. 60 times 5 over 9. How do I get it to? Oh, no. Anyways, it did more. Okay. All right, so let's go to the next problem. I am now going to have a fraction in the numerator and I'm going to have a fraction in the denominator. That means that I need to focus on solving whatever's busiest. Look at what's busy. This numerator has a lot going on. I actually need to add those. Because on Monday I said, hey, if you want to get rid of a fraction in the denominator, you multiply by the reciprocal, right? So whatever's in the denominator, you multiply by the reciprocal. So right now, I really need to just focus on the numerator and get that simplified. So step one that I'm going to do is I'm going to add the top fractions. Step two of what I'm going to do is I'm going to then multiply by y over 1 to top and bottom. Because I really don't want a fraction in the denominator, ever. And then check this one out. On example 5, I'm going to have to add the denominator first and just completely ignore up above. So it's kind of like reverse problems. So that's good. You work with whatever's busiest. You have to add something first, add it, get it into one fraction, and then I get rid of the denominator. So I'll do these slowly both with you. Okay. I'm going to ignore the denominator right now. Not even going to care what it says. I need to add those numerators, those two terms. So I need to first find a common denominator of x and x plus 1. So the common denominator is both of them together. X, parentheses, x plus 1. Okay. So this had a 1 on the numerator, this had a 2 on the numerator. What did the first fraction had an x in the denominator? Now it has an x, x plus 1. What do I need to multiply by to make it equal? Volunteer.
X plus 1.
Thank you, sir. This had an x plus 1, but now I've got an x plus 1. What do I need to multiply the top and bottom? Well, here's the x on the bottom. What do I multiply the top by?
X.
Thank you. So now, let's add. The denominators are the same. X plus 1 plus 2x. Okay, 3x 1. Right? My numerator is now just one fraction, which makes my life so much easier. So here we go. Put it back with a 1 over y in the denominator. Basically like, now I can bring back the denominator. And I'm going to clear the denominator, multiply by its reciprocal, which gets me, y is gone, 1's gone. Yay, my denominator is gone. All I worry about is now what's on the numerator. It's a multiplication problem. 3x plus 1 times y. Let's put the y in front. Over, and then the x plus 1, because that's all I can do this. I cannot break apart this 1 and this 3 and this x. If it's connected with an addition sign, that's a binomial. You can't break apart a binomial. Do not try and cancel out a 1 or cancel out this x here. If it's in parentheses, it's protected. If it's connected with an addition or subtraction sign, it's together and you're not breaking it apart. Okay?
So that applies to 3x plus 1 over x, or like parentheses x plus 1. So you can't cross out the x.
No, you cannot.
Miss Grant, I have a question.
Yep.
So on this, on like this, questions like this, when there's a fraction in the denominator, do you always have to make the fraction go into the numerator?
You have to first, I had to add the top part before I could even think about doing the reciprocal in the denominator.
I know, but like if instead of a y, a 1 over y, what if it was like a 6? Would you still have to do that?
Yeah, I would.
So it only applies to when there's a fraction in the numerator.
Correct. If there's a fraction in both the numerator and the denominator, then you got to do all this extra work. And that's what's going to happen on example 5 as well. So on example 5, I have a fraction in the numerator, but that's okay for now. But the denominator is complicated. There's an addition problem there. So I need to actually add it, simplify that, and then go from there. So that means that I'm going to first ignore the numerator right now. I need to add the denominator. That's what I need to do for number 5. So let's talk about how that's going to look. You're not touching the numerator at all right now. I'm going to find an LCM for this addition problem right here. What's the common denominator of 3 and x minus 1? Someone brand new. Nope. Someone brand new. LCM of just these denominators. Nope, you've helped. Nope.
Okay.
3 times the quantity of x minus 1.
Excellent job. So that looks great. And now I want to rechange my numerators. There was an x plus 1 over here, and there was a 4 here. So now, in purple, this denominator had a 3. Now it says 3 times x minus 1. What do I multiply the top by?
X minus 1.
Yay. Ooh, that's a binomial times a binomial, you guys. I better pay attention to that and make sure that I FOIL properly. Let's go to the second fraction. Originally, I had an x minus 1 in the denominator. Now I have a 3 times x minus 1. So what do I multiply by?
3.
3. Good. Okay. X, notice how my finger's still stuck there. My finger's stuck there because I don't want you to care about the numerator at all. FOIL. Hey, x plus 1, x minus 1. X, difference of 2 squares, right? X squared minus 1 plus 12. That's the numerator simplified over 3 x minus 1. Well, x squared minus 1 plus 12 is x squared plus 11 over 3 x minus 1. I am done with my denominator. Now, ready? Make it a big fraction bar. Okay. Here's my numerator. It's a fraction. Here's my denominator. It's a fraction. I need to clear my denominator. How do I clear the denominator? I talked about it on Monday. I don't want this to be a denominator fraction. No. How do I clear it?
Multiply by the reciprocal.
Yes. Here we go. Reciprocal, 3x minus 1 over x squared plus 11. Whatever I do to the bottom, I do to the top. My denominator is going to cross cancel out. Boom, 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 right? Here's what I got. Let me just write it again to keep our brains like organized. By the way, when I multiply fractions, let's just put it over one giant fraction bar. Is there anything on top and bottom that I can cancel out? Is there anything on top and bottom? Oh, x minus 1, x minus 1. So that means the only thing I have on top is a 3. The only thing I have on bottom is x squared plus 11. Okay. So let's recap real quick. Example 4 and 5. Add what you need to add, because that's the busy part of the fraction. You need to clean that up and simplify that first. Then you look at whatever's on the denominator after you've cleaned up and simplified and added. And then you do the reciprocal of the denominator. Look at my finger, my 2 fingers. I did the reciprocal of the denominator. So all I had to worry about was the numerator. All right, I only gave you 2 problems for homework. One of them is a word problem, just like the one we did. The next one is a problem like one of these, okay? Let me stop the recording.